Another clear night in March, and I'm gazing at the Orion Nebula, everybody, and hope that you do some backyard stargazing this weekend. I'm Marquette, and I'm so glad that you're with us today to stay curious. As you all know, the American Space Museum for almost 4 years, and our 1033rd episode, 1003 episode. We're so proud that you're watching us and enjoying some space history, and we're going to talk a little bit about the Webb Telescope today. Some of these discoveries that are revolutionizing astronomy. You better believe that. I'm just going to tease you with some of the headlines I get on my Daily Mail, and we're going to talk about what else we're going to talk about. Yeah, these Webb discoveries, and we're going to take you into the sky with a sure sign of spring, and that is Leo the Lion. Leo the Lion's on our green screen behind here. Leo's rising in the east on his tail, a sure sign that spring's just around the corner here on March 6, 2024. I want to say hello to my good buddy Marty Winkle in the house. Marty, hello.
Hey, hello, Mark. How you doing?
Well, Marty, you and I, to tell him who was in the house, I'm on cloud nine. We were trying to, who was in the house today here to visit us. Tell him.
Astronaut Don Thomas
Yeah.
flew 4 missions.
Great guy Don Thomas was here to talk to Japan, Florida high school kids that come from Japan to Florida, tour the Space Center, come to our museum. Thank you, Tanique and Minori, the ladies that are leading that, coming here for years. Karan Conklin's been involved with them. Our executive director, Karan, knows them very well. And just about 45 kids in here. Good buzz here with Don Thomas laying on them a great program. And then he's hanging around here autographing a few things. We're taking pictures. And yep, Don does want to be on our Stay Curious program, one of the Ohio Knots. So 24 astronauts from the great state of Ohio. And Don, thank you for all you do. And we will have him on Stay Curious. Let me put my binoculars away here. We always talk about the Woodpecker mission, STS-70. Don's birthday's coming up May 6th, so we'll be giving him a shout out there too. So always exciting to meet our astronauts, but he turned around and wanted to shake Marty's hand because he feels strongly that the space workers like Marty Winkle are just the fabric of their entire missions on there. So good day here. As always, you never know what's going to happen, but we always know that Stay Curious is going to happen. And that'll be way out of whack there, Marty. Let me move those up here as we're looking at. We're going to talk about daylight savings time and a little stargazing, but there's our stargazing picture there to remind you that the moon is 25 days old. Now, I've asked you to speak like an astronomer, 25-day-old moon, that means if the first quarter is 7 and full moon is 14 days old on a 29-day orbit around the Earth, 25 days, 25 days is after last quarter, so it's a crescent in the morning sky, and that is yippee for stargazers like me because we can go out and not have the bright moonlight fog out, so to speak, or mask some of the brighter, fainter objects like the Orion Nebula, the Owl Nebulas up there, all kinds of good things to see for your backyard astronomers. And we'll tell you how to do that. But first, we want to remind you that we have an auction this Saturday to keep our doors open. QR code right there will take you to where you can bid now on 360 plus lots, including a real Rocketdyne engine, folks, that's going to go for maybe $100,000. You might have that kind of money to drop and make a beautiful display out of it in your home somewhere. But Bid Again Auctions, and our collections analyst, Chuck Jeffrey, who's also our chief operating officer. Chuck will be conducting this auction beginning at noon. It's about a minute per lot. So if you're just interested in space shuttle stuff, the whole auction is set up in chronological order of the NASA programs, from the early unmanned programs like Atlas and that launched the Ranger spacecraft to the moon, to Mercury astronauts, Gemini, Apollo, shuttle. So if you're just interested in the shuttle, you'll have a good by 3 hours until you get into those lots. So that'll probably be around 3 o'clock. Marty, you got something on your mind there?
Yeah, they can also bid on the Mylar from Apollo 12 and 17. Don Thomas said he bought it at a couple of auctions ago, which surprised me when I felt honored that he would buy that.
Well, I was surprised. Yes, and he wanted to meet you because of that. And he, when I'm showing him the workers gallery, I pointed out your photograph up there. I said, "Here's Marty Winkle, my co-producer. We put this together." And he goes, "Winkle?" He goes, "That's familiar to me." Don Thomas said, "I bought some Kapton foil off of Marty Winkle," and so he was pleased to meet you on that. You didn't give his money back, Marty, but you said you'd give it to him free next time he wanted some. Gee, that's kind of interesting. You never know who's buying stuff on the auction. Their astronaut Don Thomas buying something for his space cave at his home. He told me he lives outside of Baltimore, Maryland, does a lot of good stuff at the Udvar Hazy and Smithsonian, just like our good friend Tom Jones does. So auction time, bid till it hurts. This is a way to financially support our museum. We are a legal Florida charity nonprofit here, and this is a big deal to us. And there's a lot of great lots. We'll feature some more of them tomorrow on Stay Curious. Shuttle Fest 3, April 13th at the Hyatt Place. Talked to artist Chris Calley not too long ago. Chris is excited to be there. He's going to head a panel discussion of art in space with photographer Mark Usiak. We're going to have space artist Tim Gagnon, who designed our shuttle shield. We're calling this piece of art the shield. And we've got Ron Woods, absolutely fabulous watercolor and other medium artist that paints things of spacesuits. And Ron was a spacesuit tech for NASA. And as a youngster, he put the Apollo 11 crew in their spacesuits in 1969. So Shuttle Fest 3 progressing along. We're trying to effort some astronauts. As we get stronger, astronauts will want to come to this or feel left out. But right now, it's always hard for us to get ahead of the curve here to get them lined up. But we'll have a couple astronauts there. And we have 14 humans off the Earth right now. Earthlings orbiting Earth, number 14. We've got 11 on the International Space Station, starting Expedition 71, and 3 Chinese orbiting in their Tiangong space station there. The Crew 7 is coming back Saturday. Don't know what time of day that is Saturday. Marty, if you know, or somebody out there, I haven't seen that yet. If it's at night, we'll be able to see them streak across, maybe as they're going to land either an Atlantic side or the Gulf side of our Florida peninsula. 614 humans have orbited the Earth, 76 women, and I pointed that out to Don Thomas a little bit ago because we have a sign in our museum that says that. And I said, "You're just one of 614, Don," and he said, "It's amazing, isn't it?" So really, Don Thomas, what a great guy. I'll post a couple pictures of his visit here after our show. Again, emphasizing that, and Marty came up with the name Karmanauts for those that go suborbital. But so we got Rob Mecklenburg here from the Netherlands. Rob, thank you for sitting in here and watching us and staying curious, my friend. Safe trip back, okay?
Maybe tomorrow.
We'll see you soon.
Yeah, see you soon.
And I'm a Formula One fan, so we're watching Verstappen just stomping on everybody on there.
He's a world champion again.
He is making the Dutch proud with his record-breaking Formula One drive. You better believe it. So drop me a line anytime, Rob.
Stay curious.
Thank you. All right, buddy. Well, the JAXA rover, lunar lander that flipped over on its side, reactivated in the lunar night, and it's taken some pictures. That's kind of cool. The Intuitive Machines did shut down. It will go through another lunar cycle here, and maybe in a few days it might wake up, but probably not. It does have solar panels on it, so just a little update on the JAXA came alive again. So there's where it is on the moon from a lunar reconnaissance orbiter photograph there. Let's talk a few minutes here about astronomy, as I got my astronomy vest on. We're also going to about the Webb Telescope. Many of us get a lot of emails, and I constantly get emails about the Webb Telescope has revolutionized astronomy. Webb Telescope finds a galaxy where it shouldn't be. Webb Telescope has discovered stars younger than we thought would have formed at the beginning of the universe. Now, there is the Webb Telescope. It has all those hexagonal mirrors that were folded out origami style. The whole thing was in a capsule on the Ariane 5 rocket, launched Christmas Day 2 years ago. But the Hubble telescope is about one of those hexagonal segments there, okay? So it's about 9 feet across. This is over 27 feet across. And its light gathering power is unparalleled. It's working perfectly. And to set the stage here about some things that I don't want you to glaze your eyes over, I'm going to encapsulate them as quick as I can. Some of this high astrophysics that the Webb Telescope is just revolutionizing. But let's set the stage that we think the whole universe began 15 billion with a B years ago by what's called the Big Bang. A singularity point ignited, blew up, and within the fractions of a second of that Big Bang, about all the ingredients that were necessary for the universe sprung out of this. Now, how that happened, where that came from, nobody knows, and nobody will probably ever know. But what we're learning about the early universe is that it is more complete than we thought it would be in the beginning. We thought the Webb Telescope would be seeing galaxies in their infant structure, all right? And instead, they're seeing galaxies fully formed maybe just 1 billion years after the Big Bang. And this was not thought about in theoretical models. So anytime you look through a telescope or look up in the sky, you're looking back in time, all right? And when we're looking at the moon is a half a second away. That light is 240,000 miles away. Well, light goes 186,000 miles a second, so it takes almost a second for that to reach us. When we're looking at Jupiter through a telescope, it is as it appeared about 20 minutes ago. That's how long the light travels from Jupiter to my eye in my backyard telescope, 1 billion miles away. So setting the stage that we're looking back in time with a telescope, trying to see things that happen. And I know that's a confusing concept already to many, but just keep that thought. So here's some beautiful imagery of the Webb Telescope of some known galaxies. Different structures are revealed. The Webb Telescope is infrared. And if you've ever seen, for example, a police infrared camera, that they can drive by your house and point that at your house, and they're going to see the heat signature of your cat above the couch, and you sitting on the couch, and somebody else sitting in a chair watching TV. You can actually tell who's in the house through the walls, all right, by the radiative heat that's coming through, sensed by these infrared sensors. So that's what's going on with the Webb Telescope, is it's actually seeing through a lot of cosmic debris and clouds to see what was created behind them. And we're going to talk about what it has found and discovered are galaxies that look like, Marty, the early galaxies the Webb Telescope we're thinking about look more like surfboards or tennis balls or frisbees than they do the galaxies today. And we're going to show you photographic evidence of that. One of the first stories, the early universe, the gas between the stars and the galaxies, we thought, when that Big Bang happened, would be like a big smoke cloud, and you wouldn't be able to see through everything. Well, the Webb Telescope has pinpointed new data that the galaxy stars emitted enough light in the first 100 million years of their creation to heat and ionize the gas around them, and like a sunlight on a fog, clear up the early universe that was kind of expanding, and it's still expanding. Expanding into what and how big, we don't know. But that was one of big discoveries of the Webb, that the early universe isn't clouded up like a fog. It is cleared off by the radiative heat of the stars in the infant galaxies. Well, this picture that I showed up there, this is an actual Webb telescope. This is not a Webb telescope. This is a combination of a bunch of telescopes on the Earth, the Atacama Large Array, that combines telescopes on different mountains and in an interferometer type of way. And what this shows, the blue region shows where areas where they have detected signs of water vapor in a distant star system. This is a star system that is 450 light years away. It's in Taurus, which is up in the sky overhead right now. And technically, it is still a protoplanetary disk. This star is a young star. It's forming planets in the ring around it as debris collides together and clumps together like pieces of clay, getting bigger and bigger. And that blue light is water vapor. 3 times the amount of water vapor contained in Earth's oceans has been detected in this primordial solar system called an exosolar system, from this astronomical array of telescopes that are in a lofty Chilean desert high up in the Andes Mountains up there. So this is a very exciting thing for astronomers to realize, that there is H2O. Now, this form of this water is hydrogen and oxygen molecules that have formed water. What form the water is it vapor? Is it actually liquid floating out there in space? It'd have to be heated up or frozen ice. But this is what's going on there, and this is very exciting. So they'll be turning the Webb telescope on this. Now, another big headline in the newspapers was Webb telescope discovers the first generation of stars in the universe. All right. So we always want to know is, once this Big Bang started, how did stars begin to clump together, create massive gaseous blobs that the gravity imploded on themselves and created a nuclear reaction of fusion to turn that hydrogen into helium and create light as well as energy? How did all that happen? We don't really know, but what we're looking at here in the upper right-hand corner is one of the first stars, proof of a first-generation star is in one of the most distant galaxies known. This galaxy was known by the Hubble telescope in 2015. Remember, we got the Hubble working in consort with the Webb, a beautiful thing that astronomers never anticipated, because the Hubble is over 30 years in operation. What was considered that this galaxy was the most faraway galaxy known, so it makes sense to talk about how long that it has existed. Well, they think just 430 million years after the Big Bang that light started emanating from this star. All right. Now, they say in comparison, the universe today is 13.8 billion years old. Now, I said 15. I rounded it up there. But somewhere around 15 billion years ago was the Big Bang. So this is a typical photograph of the Webb telescope. Most of those images in there are not galaxies. They are not stars, they're galaxies. All right. So we found the new stars like we wanted to. I know these pictures don't mean a whole lot to you, but they do to astronomers. This is the Spitzer Space Telescope, okay. Improved view from the Webb telescope on the right, all right, showing you tracking back in time that they have discovered faint galaxies that formed early in the solar system, didn't have very luminous stars. The stars were not super bright stars, sort of like our sun. Our sun is an average Joe Schmo star. It's not an exceptional star in any sense of the word. It's actually called a dwarf star, a dwarf yellow star, at only less than 1 million miles across. Well, the observing power of the James Webb Telescope has allowed astronomers to zoom in on these faint galaxies like never before, and Uh, they have found several that are just local to us, 3 million light years away, but they're actively forming stars still, and some of them are as old as maybe 13 billion years old. So the evolution of galaxies and stars are sort of the same. The stars can get old, get big, use up their gas, explode into nova or supernova, and then as these stars are depleted from a galaxy, the galaxy sort of turns off. Now, a lot of galaxies also have star-forming regions where new stars are being born, and incredibly, some galaxies might be as old as the universe and have been around all that time. And this is a study, again, that the Webb Telescope is investigating. Now, let's have some fun here as the Webb Telescope is finding that while it's solving some of the great mysteries of the early universe, the powerful telescope has also found that many distant galaxies have flattened oval shapes, tube shapes. They're shaped like spiral and elliptical structures. In fact, some of them look more like frisbees, volleyballs, swimming pool noodles, and surfboards. Okay, all depicted here. In fact, 3 distinct shapes of the early universe have come about by the Hubble. You've got your elongated appearances. Look at those surfboards there, Marty, on the top. Then you've got disc-like appearances, like our Milky Way is like a pinwheel. And then you've got spherical structures over my shoulder here, like look like volleyballs. So researchers have found that the surfboard and pool-shaped galaxies were significantly more common when the universe was 600 million to 6 billion years old, half of its age now till its infancy. This is a stark contrast to nearer galaxies, which are often clearly defined spirals with star-studded arms, okay? So, continuing the beach metaphor, the Webb team explains, nearby galaxies are often clearly defined spirals with star-studded arms, which resemble frisbees or smooth ellipticals, which also look like volleyballs. While the most distant galaxies, all right, look like surfboards, pool noodles. Others are shaped like frisbees or volleyballs also. So this is a constant shape of gravity that we don't understand, being shaped by this mysterious matter called dark matter that incredibly, of all the bright objects and galaxies and billions of stars, we can't see 90% of the universe's weight. Its mass is hidden from us. It's not in these bright stars and planets. Where is it? It's in what's called dark matter, which is in a sense maybe a permeated cloud like fog that is everywhere in our universe. But that's something else for the Webb Telescope to tell us years down the road. What would our Milky Way galaxy look like if we turned back the clock a few billion years? Our best guess is it'd look more like a surfboard, okay? And here's some of these shapes again that the Hubble is picking up on the earliest galaxies. These are computer simulations of some of the galaxies going on there. A prolate above my head, that's the pool noodle looking thing. Oblate is the frisbee, and then you got an oval, kind of like a surfboard. All right. So the discovery of what we call gravity waves, all right, associated with this dark matter. Now I'm losing you, but gravity waves were said to exist by the great physicist Einstein, all right? And Einstein predicted that if you had particularly very massive black holes orbiting each other, that would create a gravity wave like waves on a beach emanating, rippling through the whole universe. So and there we've got Einstein surfing on one of them gravity waves there, okay? Doing he's not hanging 10 there. He's on the back of the board, but you get the idea. So we got galaxies shaped like surfboards, and we think there's gravity waves out there that Einstein predicted in our solar system, not our solar system, our universe. So, all right, finally, one of the Hubble telescope and Webb telescope discoveries that hits my inbox that piqued me the other day. It said, "We finally know what turned the lights on at the dawn of time." Okay, who flipped the switch? As we look at a Webb Telescope photograph again, there's only one star in this picture, and that's got the crosses through it. All right, that's a star in our own galaxy. The rest of these images are galaxies far, far away. And some of these little red ones, like that one right there, that one, and that, those could be like 12 billion light years away from us. All right, everywhere we look, we see the same thing: galaxies everywhere. Well, faint galaxies play a definite role in this that the Webb can detect with its radiation signature. But at the beginning of the universe, within minutes of the Big Bang, space was filled with a hot, dense fog of ionized plasma. What little light there was couldn't have penetrated this fog. All right, it cleared up quickly, as I told you earlier. Photons would simply have scattered off the free electrons floating around, effectively making the universe dark. But as the universe cooled about 300,000 years later, after the Big Bang, protons and electrons began to come together to form neutral hydrogen, and most wavelengths of light could penetrate this medium. So this is where it cleared up, the fog. And the first stars delivered radiation that was strong enough to peel electrons away from their nuclei and reionize the gas. By this point, the universe had expanded so much that the gas was diffuse. And about a billion years after the Big Bang, the end of a period called the Cosmic Dawn ended. And the universe was truly reionized. Ta-da, the lights were on. So it took about a billion years for light to permeate everywhere in our universe. So I know that really makes you think a lot about science and just how much we don't know, the more we know. And so just a little tease there of some of the discoveries of the Webb Telescope and some of the other telescopes around the world, in fact, and the Hubble, that are always revolutionizing how we perceive our universe. So we'll have more of those stories hitting my inbox on Stay Curious. So well, let's do a little bit of astronomy in the backyard. As I said, let's see, go forward there. There we go. Got my star map here. Didn't grab one close by here. I usually have one handy here, my star wheel. But this is the free website called Sky Maps, where has a lot of great information. You can download the sky for the evening of March 2024, okay, in the Northern Hemisphere. This is the blue is the winter Milky Way, not as dominant as the summer Milky Way, of course, but nevertheless, it's still there. And you go out at night, and you're going to look to the south, and you're going to see the Orion constellation. Above it is Taurus and Gemini, the twins, and below it, the brightest star in the sky, Sirius. We've talked about those on some of our Stay Star Curious programs. But those are going to be setting pretty quickly. And in the east, when you look to the east, there's not as many bright stars. There's a couple real bright ones. One of them is a bright goldish star that's high up, and this is the regal star Regulus of Leo the Lion. Now, when I said that the moon is 25 days old today, to teach you how to speak like an astronomer, yeah, the moon is rising about 3 in the morning. It will be above the eastern horizon before sunrise, looking like a crescent there on the far left. We're very familiar with the crescent of the 3-day-old moon in our following the sundown in our west, but not many of us get up early to see the moon at the fingernail phase, if you will, in the morning sky. So 25-day-old moon, now you're talking like an amateur astronomer. That means, wow, it's going to be, if it's clear all night, the sky's going to be awesome because there's no moonlight to drown out those faint fuzzies, all right? And so this is what astronomers go up on the mountains, out to the beach, looking for dark sky areas. This weekend will be a perfect weekend to do some serious stargazing, as it will be new moon and there will be no moonlight to hamper your photography or night vision. Let's look at a bit at the skies we're looking at it. We've got a couple bright stars, Regulus, Spica, and Arcturus as you look directly east. And here is filled them in a little bit with the dots of their constellations in there in the sky. Get a star map like this and you can figure all that out. And the Big Dipper is rising in the northeast. It's standing on its tail just like this, the Great Bear, and the asterism of its hindquarters, the Big Dipper. And about 3/5, all right, expanded like this, your arms expanded across, that's 10, 20, it's about 30 degrees across the sky, will get you to the backward question mark or sickle. A sickle was an instrument used to slice hay down or other things, not a machete. It's got a distinctive curve to it. And the bright star Regulus. So Leo the Lion is easy to see. It's standing on its edge. You see the backward question mark dotted by Regulus, very bright star. And then the hindquarters are a right triangle. And among this, now we're getting into where we're looking out into the distant universe in the springtime. So there's not many bright stars in our area because we're kind of looking at out the back window, if you will, of the car. Well, we were just looking out one of the side windows with all the bright stars of the bright stars of the winter sky, and we're looking out the front window into the Milky Way, going right into the center of our galaxy in the summertime. So you got to consider we're on a racetrack going around the sun, and at different areas of that racetrack of our Earth orbit, we're looking at different grandstands as we circle the Daytona 500 racetrack, so to speak. Well, there is a beautiful rendition of Leo from the 1800s. A lot of the astronomers made maps and had artists embellish how they would consider that the lion would look in the sky. And many of you are lost at seeing these type of things in the sky, and that's okay. It's all part of the mythology and all part of the human psyche to create patterns and so forth that we can easily identify. But this is the classic look at Leo, all right, with the backward question mark. Those are the Greek alphabet, the numbers there, giving as far the lower numbers of the alphabet are fainter stars. Alpha, beta, gamma are the brightest stars. So Regulus is Alpha Leo there. And those M numbers on the bottom are galaxies that you can see with your binoculars or your telescope. They're just going to look like faint little dust balls, but nonetheless, they're there. This is another stylized way to look at Leo the Lion with the same stars. Same stars, but a little different stick figure configuration. Maybe looks more like a lion to you, but CA is Regulus, and the backward question mark goes that way. So here's another look at some of these bright stars. Regulus is bright because it's only about 50 light years away from us. The nebula, on the other hand, is bright, but it's 1,000 light years away. If it was put where Regulus was, it would shine and cast a shadow at night. Also, a lot of Arabic names. The nebula, Zausma, Algeba, Rasilas, okay? These are Arabic names that Arabic astronomers gave to the names of the stars, while the Greco-Roman mythology is where we get the names of the constellations. And then you've got the Greek, I showed you here the Greek letters for the names of stars that aren't named. And then once again, just another star map. Get your star map, get out under the stars, and enjoy a little bit of the springtime coming on us here. You will not regret it out there. So Leo the Lion, look, every time I see Leo the Lion, it's an immediate sign that spring's on its way, particularly when I lived up in Tennessee in the cold weather climates. You're like going, Finally, I see Leo the Lion, and Orion, as much as I love it, is going to be setting quickly behind me with all those beautiful winter stars and constellations. Well, Dave Stange, you're up in Michigan welcoming Leo the Lion, I know. Tom Usiak is in Pennsylvania. Steve Jokums, thank you for watching. Brother Mark Usiak is on today. Gary Gerald is, I wonder if them Vidalians are peeking up out of the ground yet up there. I bet they are up there in Collins, Georgia, where Gary's a farmer. Cliff Watson's in Australia. Cynthia Rossi, local here, as is Carlton Bailey. Bill Whiting, and Doug Forrest is watching today. And Doug, we showed astronaut Don Thomas your beautiful Endeavor sketch. He already signed it on there. So Marty had that out. But then Matt Pike, thank you for watching, Matt, and joining our Stay Curious family here today. Yeah, Marty, you got a comment?
You want to show it?
Have you got it? Yeah, sure. Yeah. Marty has that here. We'll show you what we talk about. Doug Forrest's work of art here, the nose of Endeavor, which is out there at the Los Angeles Space Center there, Los Angeles Science Center. There we go.
There's 41 signatures on it.
41 signatures on it. Let me go. There you go. This is what we're talking about, our friend Doug Forrest.
Zoom out. Hang on.
Here, I've got it right there. There you go. Andy Thomas is right there. Don Thomas is right there. Okay. And he thought that was a photograph, Marty, at first. Of course, everybody does. And Marty's been going out there, his personal quest to get all these astronauts autographing that. That's silver ink. Okay. I was going, that looks awful white, and that's silver ink on there. So a lot of great guys and girls on there. And, Don Thomas was so appreciative of the space workers here. He really is. But beautiful. And you can go to Apollo Arts, I think, .com is where Doug Forrest, 2 R's in that Forrest, sells some of his beautiful work out there. So, Marty, great idea to do that. And let's go out today with making everybody sad that you get 23 hours of daylight on Sunday. And, of course, we astronomers don't like this because we gain an hour of daylight at night, shifting it from the morning. That's another hour we've got to wait for it to get dark out. And come June, my God, it don't get dark till 10 o'clock. So, you have to stay up till midnight or 1 o'clock to do some serious stargazing. And yet, in the wintertime, I can throw the telescope out at 7 o'clock and be done at 8 or 9 and have a good, fun time stargazing. So, we go forward, 23-hour day. If daylight savings time were always in effect, you're going to see this battle for this all the time. Days with reasonable sunrise time, 7 a.m. or earlier. Nowhere in the country has 7 a.m. or earlier. Okay. Days with reasonable sunset time, 5 p.m. or later. Everywhere in America. Okay. So there's always a case to keep daylight saving time in effect. The bummer is, of course, when it gets dark at 5 o'clock. In January, and everyone, and then in June, July, doesn't get dark till 10 o'clock. So big difference to the rhythm of a lot of us here. So doesn't matter. You're going to lose some sleep probably on Sunday, and you're going to see a lot of memes out there, okay, on Sunday. Is daylight saving a form of time travel? And, of course, that's from Back to the Future, very famous movie, decades and decades ago, still holds today, I think. So that's our program today. We want you to get out there and do some stargazing like we've done a couple weeks ago with these homeschool kids out here in our parking lot out here. Had a big time looking at Jupiter and the moon a couple weeks ago. We love doing that. We hope that we get back into doing more of that. hard again to do in the summer, because if it doesn't get dark till 9:30, you know, who's going to come out and stay till 11 o'clock and then, you know, go back home. So thank you, everybody, for watching today and staying star curious with us a little bit on Stay Curious. And, of course, we're always excited to have special guests in our museum like astronaut Don Thomas. I'll post a few pictures here in a few minutes of this great group of Japanese students that were here, hearing him talk and being inspired. And I heard him talking. He loved the questions they had from this group, and we love our astronauts that find our museum. Don's been in here several times, and yes, he will be back and do a Stay Curious program. I got his business card in my pocket here, and we'll keep him apprised of all of our doings here at the American Space Museum, and that includes our auction on Saturday. Okay, so go check it out there. Go to our website. Up at the top, it says auctions. Click that, or get your phone out right now. Hit that QR code, and you can pre-bid. And how that works, if you want to only spend like $300 on this autograph of John Glenn, and nobody bids higher than $200 on it, then you're going to get it for $225, even though you're willing to get $300. So that's where the pre-bidding is. You put your maximum that you're going to allow. So Marty, have you put a bid in on that engine yet?
No, not yet.
All right. I know someone that bought it paid at least $40,000 for it, I think. So anyway, it's a lot of fun, a big education, and a good way to support our museum. So hope that you can find time to watch our auction on Saturday, live only, and we just showed you the link for it. So great. Anything else to clean up on our Streamlabs production there, Marty?
Well, Mark, I think your daughter logged on. Says, Daddy wore that vest at so many school talks, and I don't have my
My
glasses
daughter
on.
Jessica's on there.
I think so.
All right, with Macy, my granddaughter, and McKinley. Glad that you're all watching today, family, up there in Tennessee. So, well, we've had a good show today. Glad that you all watched it. We will hit some more of the auction and space history tomorrow on Stay Curious. Until the next time, I'm Marquette saying thank you to Don Thomas for always reaching out and bridging the space between us. And thank you all for doing the same. I'll be back again, of course, to bridge the space between us. Thank you.